Hello, this video demonstrates how you can derive a very sensitive contamination monitor from a basic Geiger-Müller counter. There are various simple Geiger counters available on the market, for example made in China, around €50. This US made Geiger counter from GC Electronics, and then there are Russian models as this from Radex or from Zirx. They all use rather small tubes. This is similar to the tube used in the China models. This also uses a small glass tube, and the Russian models typically are based on the SBM20. There are much larger tubes around which deliver more counts per time unit. For example, the SBM19 tube made in Russia, and if you are lucky you can buy these tubes as used as old items via eBay. There's also this large SE8B tube, which is a large window pancake tube. And if you are not in the mood for an electronic project, you just use a working Geiger counter model as starting point, and you attach a tube of your choice to this setup. Especially this GQ model is fine. It allows to record the data and to transfer them to a PC later on. So all you have to do essentially is to wire out the supply for the tube and to connect a different tube. I also dislike the lithium batteries inside. I typically use with non-rechargeable alkaline batteries. I then use 3 batteries in a row, delivering 4.5 volts, so the supply voltage is also coming from outside. So this is what the opened Geiger counter looks like. Essentially you have to remove the original tube and just solder the connection wires, which then go outside. Note that these tubes should always be operated with a resistor on the anode. Here it is this little resistor R2, which has a value of 3 mega ohm, and most tubes work fine with this resistor. However, the SBT10A tube, which is a big pancake tube, actually 10 separated detectors, require external anode resistors on each unit. So in this case you have to short wire this resistor and to add external resistors. This unit seems to come with different firmware versions. In the later firmware versions you can adjust the tube voltage. Some versions really state the voltage value. Sometimes it's just a percentage information. So the tube voltage should typically be in the range of 400 volts. And if I adjust it empirically, I start with low voltage and then increase the voltage until counting is starting, and then increase it a bit further to be in the plateau region of the tube. Okay, this is how an assembled unit could look like. The original modified Geiger counter is fixed on a plastic box used for electronic experiments, and this box contains batteries and the tube. In order to not compromise the tube sensitivity for beta particles, I have created a window, and this window is closed by tape as you use it for wrapping parcels. This is quite stable, but nevertheless thin enough to let the beta particles in. This unit gives you a background count per minute of around 80, which is pretty nice and is very sensitive even to weak sources. For example, this is a fossilized piece of a dinosaur. I guess it's a claw of a dinosaur, but I'm not an expert, so if you know something about it, please let me know in the comments. And if I approach with the tube, you see that the counts are rocketing up. Okay, so this works fine. This is a unit I use all the time, so it's running 24/7 since several years for monitoring background radiation. It delivers typically 140 counts per minute, and it's using an SPT-10A tube, so a Soviet large area window tube, which however has these 10 separated anodes. So I will show you how it looks inside. This is the inside view of the unit, the batteries for the supply voltage, and here the back view of the tube with the individual 10 anode resistors. I think I have chosen 10 mega ohms here. So this is a unit in operation, and I just use again our fossilized bone to demonstrate the sensitivity. So this is also working fine. Always keep in mind that the tubes are rather sensitive, so you should protect them. I use this metal mesh from a computer fan to do this. Still another example. This uses a Quarta Radex 7006 Geiger counter. After receiving it, I was rather disappointed. The 1706 uses 2 tubes inside, but one was broken, so I decided to use it for an experiment. And in this unit I have attached a pair of SE8B pancake tubes to it, and it works just fine. As all these units, it's calibrated, but you can work with counts per minutes, and it's still good to discover weak sources and to detect weak enhancements of background radiation. This unit combines a simple China-made dosimeter with a Soviet tube, an SBT11A tube, a little pancake tube with a window. Some users claim it has some alpha sensitivity. I'm not sure about it. At least it can measure rather low energy better. So this is all. I hope you enjoyed it and you are now in the mood for own experiments. Thank you so much for watching.